today I'm going to show you an example of 2D dynamics, and I'm going to have the same box on the same table. So the table, and I'm going to have the same box, and as you remember, box is 10 kilogram. And let's erase this. We know that this is an example of F equal ma, so let's write F equal ma over here at the corner. And when we talk about F, we actually talking about Newton's second law, and we are talking about net force. Now 10 kilogram box, and this is 10 kilogram box sitting on a table, and there is someone pulling the box at 40 Newton at 30-degree angle. Let's say 30-degree angle. Now let's first draw the force body diagram. Our goal is to find the acceleration using Newton's second law. So force body diagram, you have let's draw it nicely. And where is the, let's draw it nicely, force body diagram. All right, so the box, so our weight is 98 Newton, and our normal force, we don't know what is our normal force. In order to find the normal force, we have to also find Fy. What do I mean Fy? Because I have Fp, F pulling has two components, at the x direction and at the y direction, and this is at the y direction and this is at the x direction. So let's find them. So Fx, which is 40 cosine 30 is 0.87, so 40 times 0.87 is 34.64, I believe, but check this in your computer. Now shoot, 40 sine 30, which is easy because sine 30 is 0.5, so this is 20 Newton. So at the y direction, Fy is, now we know it is 20 Newton, and Fx is, we know, 30.64 Newton. Again, I'm not sure, you check it with your computer, with your calculator. Now we know what is the normal force. We know that the weight of the box is 98 Newton, and normal force is, of course, this is 20 Newton, and 20 Newton minus 98 Newton, so 78 Newton is the normal force. What does that mean? So let's do vector analysis. So biggest vector would be the weight vector would be the biggest vector, so Fg, and then I have normal force is the second biggest vector, so I'm going to draw the normal force. Normal force is the second biggest vector, so second biggest vector is the normal force. So normal force is the second biggest vector, so Fn, and then the second biggest vector is, of course, Fy. So I have Fn and I have Fy. So all together I have net force at the y direction is 0. So acceleration at the y direction is 0. Now let's see acceleration at the x direction. I see only, so this is no friction problem, no friction. So then F is equal to ma. Of course, when we talk about F, we're going to talk about net force. So what is the force acting on the x direction? We see only one force acting on the x direction, and that is Fx, which is m. M is 10 kilogram and a. Okay, so Fx is 34.64 Newton is equal to 10 kilogram a. So a is 34.64 Newton divided by 10 kilogram. So which is, Newton is kilogram meter per second square, and this is kilogram, so kilogram cancel, so meter per second square. So this is 3.46 meter per second square. So is accelerate at the x direction, with 3.46 meter per second square, because there is a net force at the x direction which is 34.64 Newton. Thank you for watching. I'll see you next time. Bye bye.